Okay, so here's the video for section 6.5, rhombi and kites. So to be honest, still working with parallelograms, just two more specific types of them. So again, all these old properties we had from before with parallelograms are going to sneak in. Now, not necessarily squares and rectangles. Um, oh, this is a rhombi and kites. It should be rhombi and squares. Oh, I just cut a mistake. Sorry about that. Rhombi and squares. There we go. Yeah. So, excuse me. And all this stuff with rectangles might sneak in. Depends on the shape, but we are still talking about parallelograms. So, yeah, we've worked with quadrilaterals that are parallelograms, rectangles. Now we're going to work with rhombi and squares, and then work with rhombi, squares, and rectangles, kind of how they tie in together. So first of all, a rhombus, because rhombi is the plural form. Singular, it's rhombus. And as a kid, you might have learned a rhombus is a diamond, because that's what a lot of people remember rhombuses as. Let me see if I can pull up a diamond shape. Yeah, here we go, like this. Um, but the primary definition is the fact that you have a parallelogram. First of all, again, parallelogram sneaks its way in there, but it's a parallelogram with all four sides congruent. Okay, so a rhombus has all the properties of a parallelogram and the two additional characteristics described in the theorems below. So before we jump to those, let's go to a video of me kind of walking you through it. So first of all, here is a rhombus on my screen or on my paper. Now again, the key thing about a rhombus is all four sides are congruent. Now, if I draw in just one diagonal, hey, guess what? That's congruent, so it's up by reflexive. These two triangles are congruent by side, side, side. More importantly, though, this angle, they're also isosceles triangles. So this angle is congruent to this angle. And hey, by CPCTC, that means this angle is congruent to this angle. The first theorem about a rhombus is the fact that the diagonals bisect the opposite angles. Now that didn't happen with the rectangle or any other parallelogram. If I just take a random parallelogram and draw it in, those two angles aren't necessarily the same. Neither are those two. Same thing with a rectangle. If I draw a really, really weird stretched out rectangle, that's the key. It's going to be really, really stretched out. Oops. You see one angle that's pretty small, one angle that's much bigger. So it's not bisected. But on a rhombus it does. And if I draw this guy across this way, it does the same thing. Where, hey, another isosceles triangle. These two guys are congruent. Those two guys are congruent. So a rhombus does have diagonal or opposite angles bisected by the diagonals. Another thing you might notice if I draw on the two diagonals, you might say, wow, look at those two guys in the two diagonals. They look perpendicular. And guess what? They are. The easiest way to kind of argue this is whenever you have a isosceles triangle, okay, you're going to draw that in. You're also going to then bisect the diagonals with each other. Okay. So, because it's a parallelogram, so the diagonals bisect each other, so these guys are congruent, these guys are congruent. Hey, I get four congruent triangles, and all four of those angles meet here are congruent as well. Well, if all four of those are congruent, that means they have to form right angles, which then that means the diagonals are perpendicular. Okay. So there are two big theorems specific to a rhombus. One is, if it's a rhombus, then the diagonals are perpendicular. That's actually the second one we proved. And then if it's a rhombus, each pair of diagonals bisects the opposite angle. So 1's congruent to 2, 3's congruent to 4, 5's congruent to 6, 7's congruent to 8. Yeah. All right. So let's use this in some problems. So good old rhombus. So the diagonals of rhombus WXYZ intersect the point V. If the measure of angle WZX, so WZX is 39.5, find ZY. It's ZYX. Yeah. Okay, so this is going to take some unpacking here, because some weird kind of sorting out. So first of all, diagonals bisect the opposite angles, and the opposite angles are congruent, so the bisected angle pairs must be congruent then. And what we're trying to figure out is, what's this overall big angle here? That angle Y. Because it says, find the measure of angle. Sorry, not, I can't read. Yeah, Z, yes, very good. Yeah, Z, yes, I can read. I was good. ZYX. So I'm trying to find the measure of. Well, I know that angle WZX, this angle here, WZX, 39.5, that means that has to be 39.5. Together, that makes them 79 degrees. That also means then that this whole angle here is 79 degrees. And then we had a theorem back in section 6.2 that said, hey, if you have a parallelogram, which you do because you have a rhombus, the consecutive angles aren't congruent, but they are supplementary. So if this guy's 79, this one here has to give us then supplementary angle to 79 degrees. So 79 degrees plus, we'll call it just y because we're being lazy, has to equal 180. Subtract 79. Measure of angle y equals 101 degrees. There we go. So actually ZYX, what they want to know, 101 degrees. Okay. All right, next problem. Next problem. So that one used that the diagonals are, or the opposite angles are congruent, or sorry, bisected. Now we're going to work with another set of business with diagonals of a rhombus. So the diagonals of rhombus WXYZ intersect the point V. Same thing as last time. But this time WX is 8.5, or 8x minus 5. And WZ is 6x plus 3. They want us to find x. Well, this one they couldn't have made easier if they tried, because what do we know about a rhombus? All four sides are congruent. So 6x plus 3 has to equal 8x minus 5. So subtract 6x, subtract 6x, add 5, 8 equals 2x, divide by 2, 4 is equal to x. Now the next shape. The next shape we have to deal with in this section. Squares. Probably one of the earliest shapes you'll learn, but actually has one of the more complicated kind of things to work with. Because a square is a parallelogram with 4 congruent sides and 4 right angles, which means a square is also both a rectangle and a rhombus. So rectangles both a square and a rectangles both a squares with a rectangle and a rhombus, and it's a parallelogram by definition. So all three of the shapes are squares. So every property that a rectangle has, square has. Every property that a parallelogram has, square has. Every property that a rhombus has, square has. All those guys, square is all of them. Now I like this little kind of drawing the book does here, the Venn diagram to kind of cover this. So you have every type of parallelogram. The guys here, you know, the weird kind of general ones we drew in section 6.2. Then we got more specific in section 6.3, or sorry, 6.4. We talked about rectangles, 4 right angles. Then in this section we talked about rhombi, or so you can actually use rhombuses as well as a plural, but rhombi is the kind of one the book's using. Both pairs, or all 4 sides are congruent. And then we basically said, hey, look, what if we had both properties of rectangles and rhombus or rhombi at the same time? What would we get? Well, you get a square. And my little silly joke is, it's like they had a baby, rectangles and rhombi, and their baby was a square. Now, this is kind of the part we're going to save really for class more. We'll look at a little bit of rhombus problems and square problems, but really this is what we're going to focus on in class. So I just want to spend time basically going over the theorems in the video, let you copy them down, start one problem, and then boom, we'll jump into class tomorrow and we'll start doing stuff with it. So first of all, if the diagonals of a parallelogram are perpendicular, then it's a rhombus. So if you have perpendicular diagonals, rhombus. Okay. If one diagonal bisects a pair of opposite angles, then we have a rhombus. And the key to this is actually we know we have a parallelogram to begin with. If we didn't have a parallelogram to begin with, we couldn't do this. Okay. If one pair of consecutive sides of a parallelogram are congruent, then we know we have a rhombus as well. Now this might seem kind of weird to do, but here's the key. I know I have a parallelogram. So what that means is my opposite sides are also congruent. So if one pair of consecutive sides are congruent, that means the opposite sides also have to be congruent. That's how we get our rhombus. And then the last one, this is actually really important for us, because when we get to this section in class, the question is to be, how can we prove something is a square? What we'll do to prove it's a square is, we will prove it is both a rectangle and a rhombus. And I don't know why I put, first of all, that's disgusting. A little better. There we go. Good enough to make it straight. Secondly, it says exactly what it means in this theorem, so I don't need to cover that. But if it's both a rectangle and a rhombus, then it's a square. So it is going to be kind of tedious at times to do these things to prove this. I'll prove, that the diagonals are perpendicular. We'll talk about how to do that in class. I'll prove that the parallelogram bisects its opposite. The diagonal bisects its opposite angles. There we go, it's rhombus. If we can have one pair of consecutive sides congruent, that means that the opposite sides are also congruent, so it's a rhombus. And if we can prove a quadrilateral is both a rectangle and a rhombus, we know we got a square. All right, now for homework for tomorrow, and for class tomorrow, what I want you to do is I want you to plot all 4 of those points. You got a little grid in your homework. Plot all 4 of those points, and then, like looking at it using the eye test, tell me what you think it is: rectangle, rhombus, or square, or maybe it's a rhombus, so maybe it's a rectangle, so it could also be a square or whatever. So we'll talk about that in class, and then we'll figure out how we could prove what kind of shape it is and all the different ways we could do that. So if you have any questions, come on in. Otherwise, hopefully this was not too overwhelming because there's a lot of stuff in here, and I'll see you in class tomorrow. Thanks.